Good morning.
Hello, good morning, everyone. I see that it's quite packed. Until just a minute ago, some people, they were still joining. But I think we are, well, at least, yeah, most people who have registered, they should be here by now. And as you may recall from the agenda, we have a schedule which is quite packed. So really welcome and good morning, everyone. For those of you who don't know me, my name is Andrea Lösch, and I'm a senior consultant at the Department for Multilingual Technologies at DFKI. That's the German Research Center for Artificial Intelligence. And I happen to be also one of the project partners of the LT Bridge project. So it's my pleasure today to guide you through the training session for anonymization in the context of language data. And I'm really happy to see you all online today, especially because the invitation was on behalf of a project called LT Bridge, which is quite new and which you probably don't know yet. So maybe as a background, LT Bridge is funded under the Horizon Europe program, and it only started in the beginning of this year. So to be honest, we don't even have a website yet, but this is going to be changed in a couple of days. So the goal of LT Bridge is to increase the collaboration between the University of Malta, is our coordinator, and I see that Claudia Borg, she's online too. So she's handling this whole project. Dublin City University in Ireland. So welcome everyone from DCU, and also between the German Research Center for Artificial Intelligence, DFKI. So welcome everyone from Saarbrücken or Berlin, just the same. But what we want to do is not just to foster the collaboration in general, but specifically in the area of language technologies. So machine translation and natural language processing, and even more specifically, machine translation and natural language processing for low-resourced languages, because that's what we are good at, and that's what is needed also when looking at the current market of language technologies and tools and services. So in the LT Bridge project, young researchers, they can actually benefit from dedicated training opportunities like this one. But there will also be summer schools, and researchers in general, they are also invited to our webinar series, like a scientific webinar series, which will start on 8th of June and which will be held by my colleague, Cristina España-Ibonet. And also we are organizing a WMT 2021 shared task, which is running and which is on multilingual low resource translation for Indo-European languages. So really just have a look and join, and it would be great to have you there and to see you. But I think now that's enough about our project, about LT Bridge. Let's just start with the training. You can see the agenda being displayed in a second. And yeah, there have been some slight changes in the order of talks today, but nothing fundamental. So as you can see, we will look at anonymization in various different contexts, named entity recognition, anonymization of health records, anonymization of parallel data, legal aspects of anonymization, and so on and so forth. And of course, the question arises, why is anonymization so important for language data? Well, the answer is actually quite straightforward. It's simply because it's worth it. So as you can see in the picture that Stefania will display in a moment, we currently only have access to language data which is publicly available and shareable. But that's only the tip of the iceberg. It's a tiny fraction of the language data that exists, but that cannot be used or shared at the moment because it contains personal or confidential information. So in order to make most of this big bulk of language data actually usable for machine translation or NLP development, we need what we call anonymization. Even though, quite frankly, in some contexts, it will have to be more than anonymization. It would rather be pseudonymization. So as such, I'm really happy to welcome our first presenter, who I hope has already joined, because he will shed some light into what anonymization is. And that's Marcis Pinis. He's the Chief AI Officer at Tilde, and he will give you quite good insights into the whole area of anonymization in the context of language data. Welcome.
Hi.
Hi.
How do I share my screen here? Oh, I see.
The green button, yeah.
Yep.
Perfect.
Found it. Okay.
Okay.
So I hope you see my screen and you can also see my presentation.
Perfect. We see that.
Okay.
Thank you.
Okay. Hello, everyone. It's a pleasure to be here and tell you a little bit about anonymization. I'll start by giving you an overview of what anonymization is, what are the data modalities that anonymization touches, what are the strategies, a short overview of strategies regarding unstructured data, then automation levels, so how much can we automate, and also some challenges that we have to address and or acknowledge when working on anonymization. And then I will go over the topics in a shallow manner. Later through the day, you will hear from different speakers a more in-depth dive into different tasks and different modalities and different also anonymization strategies that concern the different modalities. So what is anonymization? Anonymization is a process by which personal data is irreversibly altered in such a way that a data subject can no longer be identified directly or indirectly, either by the data controller alone or in collaboration with any other party. So in essence, this means that when we anonymize data, we should not be able to identify whom the data was about. So the individual should not be recognizable. And what may have to be anonymized highly depends typically on the domain and the use case. So for health domain, there are certain things that would need to be anonymized. And when we talk about audio or speech data, there may be a different set of things that need to be anonymized. But many of the methods share things that need to be anonymized, and those could be names of people and organizations, locations and addresses, both physical and virtual, phone numbers, date and time expressions, physical characteristics of people, age, gender, and also country-specific personal details, like if you have insurance numbers, personal identifiers, whatever each individual country can think of, those would also be subject to anonymization, and also other things that can identify an individual. For instance, if you know that someone has done something and that something is very unique, and there's only one person who has done that something, then that could theoretically also be subject to anonymization. And this actually is one of the things that may make anonymization very, very challenging for automated methods. So now let's look at the data modalities. In essence, every type of data that you could think of could be subject to anonymization. Here you see some of the modalities that will be covered today, so text and audio, but anonymization may have to be carried out also for image and video. For instance, a good example of anonymized content is when you go through Google Street View, you cannot see the faces of the people, and also the vehicle registration numbers. Those are anonymized, so blurred out. Also structured data, which will not be addressed by me, but maybe someone later on today will touch also structured data, so relational databases and graphs, and also other modalities like sensor readings, biometric data, etc. Like everything that, or every type of data that we could think of could theoretically carry some information that allows us to identify individuals, and that could be subject to anonymization. So let's now look at some strategies for anonymization regarding unstructured data. So I mentioned that I won't look at structured data, but I'll show some examples regarding unstructured data, which is also more relevant when we deal with language and language data. So these are some examples. There may be also other strategies. So we can, when we identify something that needs to be anonymized, we can potentially delete it. We could mask it, so replace it with some placeholder, or as in paper data, you could mark it out. We could pseudonymize the data, so replace the entity mentioned that is there in the text or even audio with something different, some other entity which matches the context. We could noise the data, so add some, for instance, for audio data, some white noise over it. We could shuffle the data. So if the sequence of the data is important in order to recognize an individual, we could shuffle it. And we could also filter the data. For instance, in audio, if you want to make someone's voice unrecognizable, you could channel it through a filter and transform the voice such that it's not possible to recognize the speaker anymore. So we will look at some of the examples a little bit, but not in a too high detail. So first, let's look at deletion. So the process is very simple. We identify entities and then we delete those entities. Here you see an example of news text, which is anonymized in this way. And this is a rather poor method because it has deficiencies. It breaks semantics, it breaks syntax, and it also loses context. So if you want to analyze it in a downstream task, you might face problems that the text doesn't make sense anymore. So this is a rather simple, sometimes used method, but not very useful if you have to process the data in downstream tasks. For some tasks, maybe it is useful. For many, for instance, machine translation, it would not be a sensible thing to do. The next method, masking or anonymization with placeholders. So we identify the entities and then we replace them with placeholders. Simple enough, but the placeholders, the choice of how we how we choose what placeholders will be can be more complex. So we could have entity agnostic placeholders, so one for everything. So we just mark that here is something, here is something, here is something. We have no idea what that something was. We could have placeholders that are category specific. So if you use a named entity recognizer and you identify types or categories of named entities, we could have placeholders that identify those different named entities. So here was a person name, here was a location, here was a date. So we have at least some information that helps us carry over some contextual information, but removes the information that allows us to identify the individual. And then we could also have entity-specific placeholders. So for each entity, we could use a unique placeholder that says, here was this entity, and then further down, we see that there was another entity which is the same as before. So in this example that you see here, I added entity-specific placeholders. So each entity receives its own individual placeholder. So placeholders could also be supplemented with metadata. So for instance, for text, we could use morphosyntactic information that allows us to preserve morphosyntactic structure of the sentence. So additional information which along the placeholder allows the downstream task to analyze the text easier. So this allows us to keep the syntactic structure, for instance, of the text intact, although we don't know what was in the entities. So behind those different entities that were anonymized. We could also use additional information such as gender, or any other information that may be relevant for a downstream task that we will later on carry out, such that we bring over some information that allows us to disambiguate. So all the information that we add, so the morphosyntactic information, the gender information, etc., that's needed typically for downstream tasks for disambiguation. So this is a slightly better method than deletion because it allows us to preserve syntax, and it sometimes also allows us to preserve semantics. Although we don't know what was behind those entities, we still can make some sense out of what was there. And in some cases, it's enough in order to achieve good quality results for the downstream tasks, but it does lose some contextual information. So if the entity itself is context informing, so the text, for instance, around the entity depends on the knowledge of what the entity was, then by anonymizing, we are obviously losing that information. So that's missing. But it's a good method, a practical method that is often used as a compromise. The next method is anonymization with pseudonymization, where we first identify entities, then we select replacement entities. So entities that come from the same category. For instance, for person names, we use random different person names. We generate correct forms, sometimes depending on how well our anonymization implementation works. And we replace the entities in the text with the replacement entities. So here you see an example where I have pseudonymized the text, but I have used canonical forms. I have broken syntax in the pseudonymization process. So for some languages, it would be very important that we inflect the entities, the replacement entities, in the correct surface forms for many languages. So the entities could be randomly selected from a large set of entities. They could also be common entities. So in order to make the task easier for the downstream task, we could select more common entities for which we know that the downstream task won't have problems dealing with them. We don't want to use very rare entities because that could introduce sparsity for the downstream task. And as I said, we would want to keep the inflection, and we would also maybe want to enforce consistency. So if there are 5 mentions of the same entity, we would want to have 5 replacements with the same entity, but replacement entity. But that depends on the requirements of anonymization. Maybe sometimes if this data is very sensitive, there's a need to use a different mention for every place so that you obfuscate the data more. So this is a slightly better method. It allows to preserve syntax and also semantics, but as I mentioned when I was talking about placeholders, we can also lose some contextual information if the context around depends on the exact entity that was anonymized. And it may be a very expensive method to implement because you need to have a larger set of tools available, and you need to, for each language that you work on, named entity recognizers, part of speech taggers, morphological synthesizers, which may be sometimes costly. So then the next method or strategy is noising blurring, where we identify entities and then we add some blur over them. And this is typically done for audio and or images and video. So where you see blurred faces, blurred registration numbers of cars, etc. Then the next strategy is data shuffling. So I briefly introduced that at the beginning, so I will skip over that to preserve time. And then the last one is filtering, where we read in a signal and then we transform that signal such that the original owner of the signal or the carrier of the signal, the individual, cannot be identified. And I mentioned that this is typically done for audio, where we want to alter the voice of people. So we can have multiple or different automation levels when we perform anonymization. So by automation levels, I mean how much human effort we need to use. So we could require fully manual anonymization, and that is typically applied if we don't have automatic methods, or the anonymization is required for specific entities for which we don't have any support. So then it makes it not only makes sense, we don't have any other options. Then there's semi-automatic anonymization, which is typically done for highly sensitive data. So you need to have some human supervision over the automatic tools that we apply. So the automatic tools allow us to get certain work done, but there needs to be someone who looks over that and spots missing entities which haven't been anonymized, and then anonymizes those as well. And then there's fully automatic anonymization, when and that could be applied when a certain level or percentage of non-anonymized data is acceptable. So when also the risk that non-anonymized data is spotted is is later used by someone is low, and if the chance that of a harm caused by non-anonymizing something is rather relatively low. So then we would apply fully automatic anonymization. So what are then the challenges? So we know how to anonymize named entities, but we know that named entity recognition tools are don't reach 100% precision and recall. So, and furthermore, the quality can fluctuate from domain to domain. So the obvious question is a score below 100% acceptable, and where does acceptable start? So those are questions that need to be asked when considering anonymization of a certain type of data. And also, complete anonymization may actually be a very unreachable dream, since not everything that identifies individuals is expressed only with named entities. There could be phrases which are very specific, very sparse, and allow identifying a specific named entity, so a specific individual, if you have complete world knowledge. So knowledge that is available to humans only. So no system whatsoever has complete world knowledge. And if and in this situation, it's impossible to actually reach complete automatic anonymization. So the question is that acceptable as well? So I hope those questions will be answered throughout the day by some of the speakers as well, or at least discussed furthermore. But I encourage everyone to think about these topics. So in summary, we looked at what anonymization is and what the things that may have to be anonymized are. We looked at some anonymization strategies, certainly not all, but those that are more common for unstructured data. We looked at automation levels, and we looked at two potential challenges that need to be addressed when, or at least thought about when considering anonymization. So thank you. This was a brief overview. I think I took a little bit more time, but I hope that there's still some time for questions.
Yeah, thank you, Marcis. That was a really interesting introduction. And yeah, to everyone who is attending this training today, if you do have any questions, please shoot, raise your hand, or if you like, just submit a question to the chat. From my side, I have a question, because you said that where the quality of anonymization, it can vary from domain to domain. Do you have any examples for which anonymization works really well? Any domains?
I mean, these would certainly be the domains for which named entity recognition tools have been developed, right? Once you step away from the domain in which the named entity recognition tools have been developed, then the quality starts to deteriorate. So news is the obvious domain that typical named entity recognition tools are developed for. Also, in some languages, probably medicine or medical domains are in domain domains that could be well covered. I know that there's a speaker in the schedule who could elaborate more on this regarding the medical domain. So we can ask that question also later, whether that's true that for the medical domain anonymization works well. But the domains for which named entity recognition tools have been developed and for which we have training data, those are the ones that will be well covered. Everything else, as we know, is and may be a problem. So we need to gather more data, annotate it, and then that will solve the issue.
Okay. Well, that sounds like a good solution. But what about the languages? Could you say that, you know, there are languages for which anonymization is particularly easy, or and for some others it's more tricky to deal with?
It depends for which task, right? For instance, if you want to anonymize data for machine translation, then you have to deal with, and you want to apply pseudonymization, then you need to have a lot of tools available for the, and high quality tools. So you need to have morphological analyzers, morphological synthesizers, and that adds complexity to the anonymization workflow. It's much more difficult than when working with monolingual data, where you just need to maybe replace data with placeholders, and that's fine. If you work with machine translation and you want pseudonymization, then you first have to make sure that you find those entities on both sides. Mm-hmm. So that's a tricky task as well. It can sometimes be a challenge on its own.
Okay. Yeah, then thank you. We have one raised hand, and we also have a question from the chat. So Mariam, she asked in the chat that she would like to know the difference between entity-specific masking, so in brackets anonymization, and the pseudonymization. Is it just in the second one, we keep the keys?
So entity-specific masking means that yeah, we need to keep keys for each entity, but it depends on the task, downstream task, right? Maybe we don't need to keep the keys, the information about which entity was which, if we don't want to use them further. For instance, if you send a request to a machine translation engine and you receive the translation back, you have to have a process that links back what you anonymized with what you receive in the translation. So then you would need to keep somewhere on your side, on the user's side, the information about what you anonymized and replaced with what. But if you perform some classification of the data, maybe that's not necessary, because you don't, the downstream application does not require that you keep track of what you anonymize with what. And that's the same with pseudonymization. If you replace an entity with some random replacement entity, that gets translated, gets sent back to you. If you want to have a correct translation on your side, on the user's side, who's allowed to have a non-anonymized version of the text, you would want to have a correct translation that has all the entities listed where they are. You don't want to have the replacement entities, because then it doesn't make sense, right? So you would want to keep a dictionary at your end that says what you replaced with what. But if you send it to a classification system that just returns you some category, does some natural language understanding and not natural language generation, which includes those replacement entities in the result, then you don't need that dictionary. It depends on the domain, the use case, what the downstream task is that you want to do.
Okay. Yeah, thank you for the answer. And yeah, I think I just passed the word straight to Ivana, who also had a question. Hi, Ivana.
Hi, thank you. Thank you for this interesting and inspiring introductory presentation. So I am getting actually increasingly skeptical by this because so I see there's a huge kind of chicken and egg problem because the better the anonymization should be, the more language processing it actually requires. But then this language processing needs to happen on the user side because that's the whole point, right? We cannot put the data somewhere else. So that means that before we can get any data to develop a language processing system for a new domain, such as emergency calls in our case, we have to have language processing that we can deploy at the user side so that we can do the anonymization in other ways than manually. So that's what I'm saying. It's not really a question. It's a my realization that there is a huge chicken and egg problem in this area, and I just wonder whether you have any thoughts on this, or how we can go about this, because this is a huge conundrum for any, especially like a non-production system, right? That should be developed.
You're right. You're right. I'm not sure I know how to how we would solve that problem, because if you have a new domain, then you need to have some data on which to train a language processing tool that allows you to identify those entities that need to be anonymized. If the task is or the things that need to be anonymized are the ones or the same as for a different domain. So if you want to just identify named entities, locations, organizations, dates, numerical expressions that identify physical characteristics of people, then you could use an off-the-shelf linguistic tool for another domain and start with that. Obviously, that the quality will be lower, so you will miss, the recall will be lower and the precision will be lower, because there will be domain mismatch. And that's a thing that we have to acknowledge. There's no way, there's no way to have a very high quality solution for a domain without any data, right? It's simply not possible. So there is, once you start working on a new domain, there is or will be a data acquisition period where you need to annotate some data, and then you improve the quality of the linguistic tool that allows us to identify those entities in order to perform the anonymization. But maybe for the domain, the off-the-shelf tool is enough if you are willing to do semi-automated anonymization. If a human has to go over the text that has been anonymized and try to spot whether there are things that are still missing, then maybe it's still worth to have that off-the-shelf tool, and it increases and speeds up the effort, the work that is needed to anonymize data. But you're right that off the shelf, if you take something for a new domain, you won't have a perfect solution out of the box. That would be unrealistic, I would say. And
Yeah,
then the
thank you.
question is, how much budget do you have to get it up and running and up to the level that is acceptable?
Exactly, and even what is the acceptable level, and who is to decide what an acceptable level is, right?
Yep.
Okay, thank you. Mhm.
Yeah, thank you. Thank you both. Any further questions? I understand this is just, I mean, actually the overview and the introduction into this whole topic. And I think we will hear from you later again on the parallel text anonymization, so where we will dig a bit more in the details. But yeah, thank you for giving this really nice overview, Matsis. And I think, yeah, we will then just move to our next presenter, to our next talk. And that is Renee Swixner, also from Tilde.
Hi.
Hello, good morning. Thank you for being with us. Maybe if I just say he's the software developer at Tilde, and he will just give you some insights on named entity recognition for anonymization. So thank you for being with us today, Renate.
Yeah. I will. I try to share my screen now, so you maybe see my presentation.
Yeah, but not in presentation mode yet.
All right.
Yeah, no, it's perfect. Super.
Okay. I'm Renee Swixner, and today I will talk about named entity recognition with respect to the anonymization. And first thing I would like to do is give some definitions of what we are talking about. We could start with the entity, which is basically any object, and then the named entity would be object which has a name or unique identifier which could be used to identify this object. And then the named entity recognition is the task of finding the identifiers of objects in a text, and also finding out the type or category. And some often used classes, of course, are persons, their names, surnames, locations, and organizations, also events, and quite many different categories could be anonymized and used and recognized. And such entity categories are mostly domain specific, of course, beyond the persons, locations, organizations, and such generic categories. They depend on the task at hand, and of course, such tasks are quite various. For example, information extraction, opinion mining. Of course, for the information extraction, named entity recognition is the key task, because we would like give a user more information about specific entities. And opinion mining, we mostly deal with the sentiment of a sentence or document, but we would also like to know what entities this document speaks. So we could know, for example, if an article talks about some politician in a very negative way, we could know that this politician is doing something wrong, and he could change something he's doing. Also, question answering and ontology population also deals with entities. In one case, we would like to give users some information about entities. In other case, ontology population, entities are instances of classes. And of course, anonymization is the task we are talking today. So the named entities, basically, in this case, are the things we would like to anonymize. So the named entity recognition is like key task for anonymization. And yeah, when we are building a named entity recognizer, we have to have some way to evaluate its performance. So usually evaluation is done using pretty standard metrics like precision, recall, F measure. But in case of anonymization, I believe the recall, which is the portion of entities in the document which are found by our system, is far more important than precision, which is how many of the found entities are correctly classified. So we should focus more on the recall, and then take into account mostly recall. But of course, precision is also important somewhat. In the evaluation stage, also there is boundary problem where usually entities consist of multiple words. In this case, in this example, we see two persons. One has first name, last name, and the second has like two first names and one last name. But in real life, quite many kinds of named entities consist of multiple words, not just 3 or 4, but many more. And in such cases, the boundary problem is quite difficult, because our system should of course find all the words belonging to some entity. But when evaluating, we could say that for some other tasks, maybe this boundary would not be so important. So then we could say that if our named entity recognizer found at least one of the words in this entity, so it's already good. But then in case of anonymization, that's probably not so, because even one word which slips past our anonymizer could ruin the anonymization. And also the categories, often we evaluate by per class basis, where if the words are marked as belonging to some entity, but this entity is wrong kind, usually it's also counted as a mistake. But when we are doing anonymization using deletion, it may not be relevant to us at all. All we care is that we found that all words which belong to some entities, and they will be deleted afterwards. But if we are doing more intelligent, like masking or pseudonymization, then we of course have to take into account also the categories and that. So yeah, when we know how to evaluate documents, another thing is also that we have to measure the recall, looking at how we are doing this task, because on the one hand, mention recall of 99%, if we have 99 correctly found entities, seems quite nice. But when we are doing anonymization, even if document contains 10 entities, and we let one entity mention slip by, then whole document may be ruined, and maybe human has to check all the documents, but in this case it will be a mistake, counted as a mistake. So yeah, for anonymization, the recall is quite important. And yeah, now I would like to talk about some approaches to anonymization. One, the like older approaches using rule-based systems where some expert builds an anonymizer or let's say named entity recognizer, which takes into account various rules like regexes and gazetteers and lists of entities, also part of speech tags and similar information we can find in the document to build the rules. And such methods are quite precise if we have built a good rule set, but building those rules which are covering all the entity types and are not talking not finding irrelevant entities is quite difficult, and it needs expert in the domain. And also quite many entities will not be found by our rules because they are, let's say, inflected in many languages. And the new entities also probably will not be found by such system. So people started looking into the machine learning methods, which in earlier times were mostly like statistical methods, and then more recently deep learning methods using neural networks are more widespread. And machine learning systems, they are mostly supervised. So of course, annotated data is a requirement, but given annotated in a large enough data set of annotated data, the results are quite good, usually on the general texts better than rule-based systems, and also machine learning systems are easier to adapt. Often we have already ready architecture and we just supply it with data annotated to accordingly to our needs, and we can train a system quite quickly. So that's the more recent approach. But older rule-based systems still work quite nicely on the data which is regular in nature, like telephone numbers, ID numbers, and then similar identifiers, where we could quite easily build a regex to find such entities and mark them. And in those cases, we get very high precision and also recall if of course there are no mistakes in the text. But for irregular entity names, such methods are not so good, but still we could build a list of entities and try to match this list against our text, which we would like to anonymize. And this method works somewhat on people names. Also addresses can be found this way, and some other kinds of entities where we can build a list to be matched. Yeah, that's about the rule-based systems. But deep learning approaches, I would like to say the modern approach started around year 2015, where we have already word embeddings, neural networks, and where we like on the left hand we see an architecture where and the first layer is word embeddings, and then there are some LSTM layers and the CRF layer on top. And this architecture showed quite nice results. And after a few years, we got pre-trained transformer-based language models, which could be used as a first layers of a named entity recognizer. Like we have this pre-trained language model, and on top of that we have some LSTM layers or CRF layers. And this inclusion of pre-trained language model into this architecture on the left showed quite also nice improvement over previous work. So basically the modern approach is using this pre-trained language model as contextual encoder, and then on top of that we have some layers of task-specific model which trains to recognize the named entities. And this approach has been shown to achieve state-of-the-art results in various languages. And it's also used in the MAPA project, where multilingual BERT is used as a contextual encoder. And on top of that, there are task-specific layers. And it also has a data set on 24 European languages. And as the result, we get a named entity recognizer, which could be used for anonymization of data for all 24 languages. Yeah. And there is also a link, MAPA Project EU, where we can try this anonymizer, which in the demo version is just a named entity recognizer and like masking tool, which masks the found named entities. And it can take in a text in any of the European languages, and it anonymizes this text. Yeah. Also for intelligent anonymization, we would like to try to build like named entity recognizer, which is able to find co-references, that's entities which refer to the same real world entity. So we could anonymize using pseudonymization techniques, where we keep some of the sense of the sentence. So, for example, in this sample sentence, we have a wife and a husband which have the same surname. And often we would like to keep this information for downstream tasks, so we could anonymize it in various ways. Of course, if we manage to keep this surname anonymized in both places as the same entity, it's better than the example in the middle, where we just replace each word with some different random name or surname. This could be done by simple string matching in the simplest way, but of course it will often not work, because simple string matching will match the entities which are of different kind, but still have the same mention in the text. And in such cases, we could try to use word embeddings or contextual word embeddings, which should be quite different for city and a woman. Or another approach would be to try and match the found mentions with some knowledge base, so to give them unique identifiers, let's say in Wikipedia or Wikidata. And this way we also could build a knowledge base, but that's a different story. Yeah, that's basically, and a very short That's it from me. Maybe there are some questions.
Yeah, thank you for the interesting presentation. Are there any questions from the audience? You can just submit your questions also to the chat if you like, or you can simply raise your hand. So it's the same procedure like before. Maybe if there's no questions from the audience yet, also one question from my side. Could you maybe just give some examples of rule-based evaluation tools and machine learning-based evaluation tools, maybe apart from MAPA?
Actually, I don't remember any projects. Yeah. We are working on the chatbots somewhat, but those are mostly deep learning methods.
Okay, so rule-based is probably, it's not that frequent anymore.
Actually, it's for some kinds of problems, it's the preferred way. So let's say telephone numbers, it's much easier to find using regular expressions or ID numbers. Of course, it's easier to match them in using regex than try to train neural network.
Okay. Yeah, perfect. So it seems there's no questions at the moment, but if anything should come up, I think probably you're still online for a couple of more minutes and just submit your question to the chat. In any case, really thank you for this interesting presentation on named entity recognition. Yeah, and I think we move now to our next presenter, who I would like to introduce. It's a slight change in the topic, and we look now at the anonymization of speech data. Marc Tomasi is professor at the computer science department at Lille University in France, and he's also leader of the Magnet team in INRIA. And yeah, I'm happy to welcome Marc Tomasi today. Thank you for being with us and for taking the time to teach us more about anonymization of speech data.
Thanks a lot. Can you hear me?
Perfect, loud and clear.
Perfect. And you see my slide?
Yes, the two.
Yes, okay, that's right. Okay, so thanks a lot for giving me the opportunity to present the work we have done in the Comprised project. So Comprised is another H 2020 project. You can follow us on the website written in this slide. Okay, I will introduce very quickly this Comprised project, and this is a joint work with people at INRIA, the University of Saarland, and the German Ascora company, and also the French Netfective company. Also Tilde, you have heard about it just right now, and the router company in Spain. Okay, what Comprised is about voice interaction systems. And as you know, these voice interaction systems are now commonly used, but that they are associated with high cost because we need a lot of data to train the tools, the technology behind that. And this data has to be labeled and transcribed by humans usually. So it's only accessible to very large companies, which are able to store also all this data in their cloud. And so together with this huge cost comes the privacy risk for the users. And also these applications and this technology are maybe not very inclusive because we have a lot of languages, accents, and we want all these technologies to be available for European companies. That was the first objective of this Comprised project. So this can be summarized at designing a fully private by design methodology and tools that will reduce the cost and increase the inclusiveness of these voice interaction systems. So in order to do so, we design privacy-driven data transformation in order to meet these privacy requirements. And for inclusiveness, we did machine translation and user personalization. And for this cost effectiveness, we used weekly supervised learning in this process, together with this availability of an SDK. And we'll focus now on the work package 2 dedicated to privacy by design. And you know, and you have seen before in the previous talks that a lot of technologies rely on machine learning. And in this Comprised project, we use speech to text, spoken language understanding, and dialogue management. For all these tasks, we need important data collection, and this is very important to improve these machine learning models. But the data should be sent to the cloud for learning, and this data should be shared between all applications made by the Comprised framework. This will reduce cost effectiveness because we can share the data, and this will include also inclusive new languages and reduce this gap for poor language and accents and a variety of these things. So we will be able to include more language. And the main question in this work package was to solve this issue. How can we do that in a privacy-preserving way? So by design, these comprised applications, they do a lot of things on the device itself. So we, from the operation branch, let's say, for the dialogue, for everything like that, for the application, let's say, of the technology, we are still on the device. But for anything that relates to the learning, we should send the data to the cloud. So the privacy question is just about learning in the cloud. And the solution we have in this comprised setting is to perform on the device some transformation of the data. So we do a transformation of the speech and a transformation of the text. And then we are able to send this neutral, let's say, or like anonymized data to the cloud in order to perform user-independent learning in that case. So we have three tasks: the privacy-driven text transformation, the privacy-driven speech transformation, and the learning on the cloud. And remember that this transformation has to be done in the device or in a personal server. So we are now I will make a focus on the speech transformation. As you know, speech, in fact, carry a lot of information because speech itself can be considered as biometric data. So from the speech, we can identify with quite high accuracy the speaker. And this is why we want to perform this transformation in order to hide the identity of the speaker, because when we can derive this identity, we can say that it's a personal data. So the main contribution of this project was to do this voice transformer and this text transformer, and this is released now as open source software. And we have done this voice transformation based on kind of adversarial learning first, and also using voice conversion techniques. I will explain that now. And we have also formal privacy guarantees for the privacy-driven text transformation, which is based on identification of named entity, like introduced before. And we provide these formal guarantees in the differential privacy framework. And okay, we have published papers in conferences with also these reports we can find on the Comprised website. Okay, so the objective of this speech transformation is to keep some utility because we want this data to be useful to train new speech-to-text models, and this will be measured with the classical word error rate. That is the number of mistakes we do when we translate the voice signal. And we want also to, as I said before, to hide speakers' identity. Sorry, this is the privacy side. So that we can distribute the data without revealing who talk about what. And for that, we have to find suitable privacy metrics, and we have worked on that. And the constraint is the following: we should be able to reconstruct anonymous speech. That is, we want to have something after the transformation that is intelligible, because we need human labeling, because we will do weak labeling after the transformation. So when we talk about privacy, we should define an attacker model. What could be the attacks? So recall that we have this voice signal that is captured on the device, and we perform a kind of anonymization or transformation directly on the device or on a personal server or something like that. That is not in a public cloud or something. So it stays in the sphere of the user. Then after anonymization, we can make this data public, and we gather all the data in a public database, so that it will be useful for downstream tasks like speech recognition or speech analysis. Okay. And okay, this should be successful, but an attacker, what will be the kind of attack? It will take data from this public speech database, and it can record, for instance, a targeted user and found some data from anyone, and try to compute similarities to try to identify who, if this user was in this public database and what he said, and so it tries to reveal the identity of the public speech in the public database. In this work, we have considered different attackers' knowledge. And the first case is the ignorant attacker. This is a kind of privacy by obfuscation, and this is generally not acceptable, but you should remark that in most of the work in speech anonymization, this is the main hypothesis. So we try to strengthen this attacker knowledge, considering semi-informed attacker. because we know what is the process of the anonymization process and the transformation. It is open source, so we know the code, but we have some parameters that are specific to the device, specific to the user. That is, these parameters are hidden, and that's why we are semi-informed. We know just the transformation, but not the parameters. Or the fully informed case will be useful in order to measure the upper bound, let's say, of what we can do. The main approach we followed was this voice VPC. We call that VPC. I will explain why. It's an X vector based voice conversion. So it's voice conversion. So we take the voice and we try to transform it into another voice. And I will explain all the terms now. Okay, so we start with this input speech and we extract some kind of features. This is the F0 feature, that is the fundamental frequency, that is let's say a kind of pitch of the speech. We extract also bottleneck features. We are using a kind of language, acoustic model, which is a neural network. And at the end of this neural network, we have some kind of features. We are making the assumption that these features are not linked to the users because they are very close to phonemes and things like that. And we extract also specific features that are called X vector features. And these X vector features represent the user, in fact. And in the anonymization step, we select a new target speaker from a pool of X vector representation. So think that an X vector is a representation of the voice of a speaker. And we introduce this new target speaker, and we do a kind of synthesis from the other features and this new X vector, and we generate a new speech. So in this chain of transformation, we have modified the voice, replacing let's say, the voice of the original speaker by another one. And we have studied a lot the way we can choose the target speaker in order to have a better anonymization. And we also perform some pitch transformation in order to mask or obfuscate the gender also, which is somehow encoded in the F0 features. So if you can see the transformation in a kind of 2D representation of the X vector, that is the X vector representation of the speakers. You can see the red dots that are female speakers and male speakers in the green part. So in the original space of X vectors, that is the representation of the user's voice, you have two distinct clusters. And after the transformation, you can observe that we have moved a lot these X vectors and focusing on some specific target speakers. And we have a mixed, we don't have anymore these two well-separated clusters of males and females. So how do we evaluate anonymization? As explained before, anonymization, behind there is a utility and privacy trade-off. the best privacy is to hide everything, so and to keep the data and not share the data. In that case, we have a poor utility. Okay, so the utility will be measured in our case by the performance of downstream tasks. So we will measure word error rate for automatic speech recognition. And for the privacy, we will do a speaker identification. That is, are we able to identify a speaker in a closed set? Or speaker recognition. In that case, we consider open set, that any kind of any speaker that does not. So there are very specific methodology in order to measure that. I won't go into details for that, but remember that the speakers have not been seen in the training phase. In fact, in that case, we measure the privacy with different measures that are very dedicated to this case. That is equal error rate. That is in very briefly. This is the value when the false alarms equals to the false positive and true negative. Okay, sorry, mistake. And the log likelihood ratio and the cost and the linkability. In fact, we have proved that the linkability is the best measure for that, but because it had some diversity that cannot be captured by equal error rate or this CLLR cost function. Okay, so for this open set verification, that is the most difficult scenario for the privacy. We obtain the following result. The baseline is when we do not perform any anonymization. So you can see that if we don't perform any anonymization, we can identify the speaker very, very well. That is, the linkability is close to 1. That is the maximum value. So this is why it is very useful to perform this voice transformation. And the ignorant attack, which is all something that we cannot, in fact, consider, but has been mainly considered in the literature before. We can observe that we can reduce a lot the identification of the speaker when we do not assume that the attacker has the knowledge of the transformation. Okay. Now, in the semi-informed case, when the attacker knows the transformation but does not know the parameters of the transformation, we obtain some results, linkability results that are very close to the ignorant case. This is the lower bound we can do. So it's a very good transformation, in fact. And we have made a distinction between lazy informed and semi-informed. When the attacker is a little bit lazy, he is not able to retrain some models to compute similarities, and we have a better result in that case. So okay. Another way to see how this transformation works, it's when you consider that a user may be hidden in the crowd, and with the semi-informed knowledge of the attacker, we can find that being hidden into a set of 50 speakers, it's almost the same that performing no anonymization and being in a set of 20,000 speakers. So we reduce a lot the probability to find the identity of the speaker. Another improvement we can do is to cut the utterances in very small pieces. In that case, we reduce the possibility to identify the speaker a lot. If you look at this diagram with a very small length of 2 seconds, for instance, whereas we have something like perfect anonymization, and while doing not doing anonymization, we still have 0.8 linkability, which is quite bad for anonymization. So this is also something we can do to improve anonymization. And on the utility side, there are different scenarios because we can measure the word error rate when we encode the data and with this transformation, and learn a new model for speech recognition on this encoded or transformed data, or we can keep the original ASR speech recognition model. So we have the 4 scenarios, that is for if the input is the original input and the ASR model has been learned with original input, then we have a word error rate that is close to 3, 4, something like that. And with anonymized input with original ASR model trained on original data, we increase a bit the word error rate to 7.5. And the other way around, we increase more the word error rate. But if we decode the anonymized data with an ASR model trained with anonymized speech, then we are very close to the original scenario with original data. So we have a small gap that we should work a bit more on that in order to reduce this gap, but the utility is quite good at the end. So in summary, in this project, we have done this voice transformation, and we have studied this effect of anonymization on open and closed sets. We have performed a lot of experiments with this speaker verification and with different privacy measures. We have considered attackers' knowledge, which this has not been done in the past, and we obtained very good results. Something I have missed is the word VPC. Why we call this method VPC? Because it was linked to a voice privacy challenge, and it was in fact the baseline of this proposed voice privacy challenge. And of course, the participants of this challenge were not able to beat this transformation. And okay, this has been done in collaboration with other researchers, but with researchers in the Comprised Project. So we keep this name BPC. Okay, so we can find more information on the Comprised website. If you want to see that, you're welcome. And there is also this GitLab repository with the available voice and text transformers if you want to play with them. Thanks a lot.
Yeah, it is me who needs to thank for this really good presentation and the insights into the anonymization of speech data. I see that there's already another question. It's from Mariam, and she would like to know more about the text transformer. Is it more like an open source pseudonymization tool for text data, or is it more like a speech to text system?
Okay, in this Comprised project, we have these two transformers, and for the text transformer, it is very close to what has been presented before. That is, we look for named entities. We applied some transformations, either placeholder to replace these entities, or word by word representation, that is changing a name entity by another name entity of the same category, something like that. Yes, it is an open source tool that is available on this website, and this can be done just for text, but it also can be used together with the speech anonymization. In that case, we have a kind of alignment tool in order to remove the name entity from the speech part, and also remove it from the text part. So we use a kind of placeholder of or silence or something like that in the voice signal in order to remove this name entity. Okay, and what I
Does that
wanted to
answer
ask
your
something
question?
about that. Yeah. Yeah, there is also another way to do that is to, as I said at the end of the talk, cutting the voice into small pieces. So we have many small pieces. In that case, the text transformer is even simpler, and maybe we can do the anonymization without any transformation of the text. In fact, because we have now several pieces of text, and we don't need anymore to apply some text transformation in that case.
Okay. Yeah, thank you so much for the answer. Maybe just one more question. Can you hear me actually?
Yeah.
Yeah, perfect. Because I've already had a look at the website, and where there's two more deliverables missing, the final Comprised SDK prototype and documentation and the final platform demonstrator. When would it be available, or will it be available for everyone to see?
Just before this meeting, I was in another meeting testing this platform. In fact, and we have some demos that can be downloaded directly on your smartphone. And I think that there will be available soon. I don't know exactly the date, but because this Comprised project will end at the end of this year, I think that before the end of this year, that will be available. Anyway, the transformers, they are already available on this ELG platform. I don't know if you know that ELG platform.
Yeah.
So you can use it from there. And for the SDK, I think it will be, well, there will be a first release soon. I think during summer, there will be a first release of this SDK.
Okay, yeah, thank you so much. We just tried to share the link of the ELG, the European Language Grid, right? From where you could already download this. We will send it to the chat. Yeah, but really, thank you for this enlightening talk. Are there any further questions from the audience? Just raise your hand or maybe send a question to the chat. Okay, yeah, Mariam, thanks also for the explanation and for the talk. Okay.
And if you want to know more about the text transformer, there is David in the audience. And David has worked on this transformation, so he can provide answers, more complete answers for that.
That's perfect. So thank you. Yeah, just keep submitting your questions to the chat if you like. I think we will just say one more time thank you for this great presentation, and we will start into our lunch break now. It was really great to have you here. If you like, and if some of you like, we will open like a virtual break room where you can just meet and chat directly. Since we don't have a real life event today, still virtual, but we thought if you just want to speak to each other or so, then let's also do it virtual. And we meet again here in this room at 1:15 after the lunch break. Thank you, and looking forward to see you later.
do some terminology disambiguation, you might circumvent or work around this context loss. But otherwise, that information is missing once you perform anonymization. So another strategy of anonymization is pseudonymization, which then, as I explained, replaces entities with replacement entities, which are randomly selected. And we could have consistent or random pseudonymization. Consistent pseudonymization may be better for translation if the MT system supports document level translation, because then you know which entity mentioned corresponds to which other entity mentioned, and that may allow the MT system to disambiguate lexical choices in the translation better. And that if the pseudonymization supports also inflections, so if we replace named entities in the same surface forms as they were originally in the text, then this method does not require actually retraining MT systems. We could just use a standard MT system. So with this method, if you followed what I explained regarding the context loss on the with the director example, this also has the context loss problem. So no matter what type of anonymization method we apply, there will be some content or context loss happening. So that is something that we just have to acknowledge and work with what we have. In most cases, it won't make problems, because translations are not that difficult in most cases, but when there's ambiguity, we might see this issue. So, and if the pseudonymization does not support inflections in the targets, in the anonymized content, then we have to make sure that we train an MT system that is able to understand the anonymized content that does not support inflections in the replacement entities. So how do we train MT systems that can handle anonymized content? Regarding the first method, we're better off using a standard MT system, because deletion just corrupts data. It doesn't make sense addressing this type of anonymization method. When working with placeholders, we need to make sure that we prepare training data such that it also contains the same placeholders. If the placeholders are one for all entities, then the training data also has to contain placeholders that are one for all entities. If the placeholders contain metadata, then the training data needs to also contain placeholders with that particular type of metadata. And when we perform anonymization with pseudonymization, we can use a standard system if the pseudonymization is creates natural text, which represents something that you would see elsewhere, or if it breaks syntax, then we need to make sure that we prepare training data in a similar manner. So the data that we use to train MT systems can be parallel or monolingual, and we sometimes use also term collections for MT system training. But the most, in most cases, we have either parallel data available only, or it comes also with some monolingual data. Here you see examples of both. So in order to prepare training data such that it contains placeholders, we have to inject those placeholders in the training data, and that we do by first pre-processing the training data as we would pre-process any, and then we generate word alignments. Typically, those can be generated using any standard statistical word alignment method. So the word alignment methods will tell us which word translates from the source language into which word in the target language, and this allows us to select randomly words which we can substitute with placeholders. So a very simple method which allows us to introduce unknown things in or unknown phenomena, and this in this case anonymized phenomena in training data. And if we would require to add anonymized placeholders with metadata, we would also add that metadata as factors next to the anonymized identifier. So the anon token that is visible here in the picture. So once we have prepared such training data, we train a system for higher reliability or stability. The NMT model needs to learn to output also alignment information. So when translating, we need to know which word translates into which other word so that we can link the source anonymized placeholder with the target language's anonymized placeholder. And for that, we use guided alignments, typically, which force that neural machine translation model to learn to produce alignments which we acquire using the statistical method when preparing the training data. One example of guided alignments is available if you want to work on it further, is available in the Marian NMT toolkit. I don't know whether all the other toolkits support guided alignment, but that's one that we typically use. And then when we translate, we receive anonymized content in input. So all the anonymization is then the task of an anonymization tool on the user side, and we translate the anonymized content into an anonymized target segment, and then the user's tool that is responsible for the content creation and sending the request to the machine translation system can then replace the anonymized translation back to the translation. So our task then is to make sure that the MT system is able to understand the anonymized content in input and then produce alignments that allow to link the user's software, the source text to the target text, and then de-anonymize it. An obvious question here is how do we handle, in this case, inflections? And the answer here is we don't. That's the task of the user, either the user system or the user himself or herself in the translation process. So we make sure that we can receive anonymized content and output translations with the anonymized content, but the correct translation of the named entity that has been anonymized is the task then of the user system or user himself or herself. So in summary, the more the source content is altered, the more context required for correct translation will become unavailable. So there's no way around that. And if the context deviates from natural text, we need to make sure that we train systems that understand that type of transformed text. And it's not possible to reach 100% translation quality, because anonymization by definition means that we lose some context. And that's just something that we need to acknowledge and decide whether that's the quality that we gain at the end is sufficient or not. Thank you. I hope there's time for questions.
Yes, indeed, there is time for questions. But first of all, thank you for your talk. Yeah, and we are ready for questions from the audience, either per chat or just raise your hand if you like. Or just unmute your microphone. We are like a relatively small group in comparison to most conferences that we have. Oh, I see Ivana.
Yes.
Hi.
Oh yeah, I forgot to raise my hand.
No problem. That's fine. That's fine.
Hey, yeah, thank you. I have the following question, namely, what about cases where it would not be about anonymizing one word? So it would not be a one-to-one mapping. So say one word translates into multiple words, or yeah, the other way around is not so much of a problem. So if a word translates to multiple words, and maybe they even get like in two different places in the translated sentence, then how would then the putting back of the original words, how would that be impacted by that? Do you have any thoughts on that?
Well, if something translates into multiple things, you still have the alignments which link the source to the target.
Yeah.
Right. So you do have that information, and then it's a question of whether the putting back is automatic, or if whether it's manual. If it's manual, then that's not a problem.
Yeah.
If it's automatic, then it's up to the tool itself to decide what to do in these cases. If one thing that could come as a supplementary question is if we have a compound and that it translates into two words or we have two words and it translates into one word, would morphosyntactic information somehow change? But then we could use not just morphological information, but syntactic information that helps us to figure out how to inflect the phrase itself from the source to the target language, and that makes things simpler, I think. So if you use just morphological information, you might have troubles figuring out how to inflect the target language. For instance, if we use placeholders, we say that this phrase has an adjective and a noun, and the adjective is in this inflection and the noun is in this inflection, and it translates into some placeholder which has an inflection, but then you have two words. So how do you inflect those? We could circumvent that by using a syntactic information along with like the inflection of the head word, for instance, and then it's a question of whether the tool that de-anonymizes and produces the inflection, whether that's actually smart enough to understand how to use that information and inflect the word or phrase in its correct translation.
Yeah, indeed. Yeah, thanks. Yeah, that's a general question. Actually, again, it becomes so that that also on the side of the user, let's say, again, this is not just a kind of relatively straightforward pre or post processing. Again, there actually needs to be language processing intelligence to do the remaining tasks of putting things back. Like we had the same issue with the anonymization task itself. It's yeah, okay, yeah, thank you.
Yeah, thank you for the question and the answer. Are there any more questions from the audience? Maybe also one question from me. I think you mentioned the MAPA project, right? Are there any experiences, how reliable a MAPA can anonymize data, actually?
I wouldn't be able to answer this question. I'm not much involved in the MAPA project myself, so apologies. I don't know. Yeah, I don't have a good answer for that.
No worries about it. Sorry, yeah. Okay. Yeah, any further questions? I'm sure we will find out. Okay. Yeah, then thank you, Marcus, again.
Andrea?
Yes, Khalid.
This is Khalid. Yes, I can probably answer on behalf of the MAPA group.
That's great.
Very
Thank
good.
you.
I hope you hear me.
Yes, loud and clear.
Yeah, so we are going to conduct a number of evaluations for the MAPA. The question is, what are the performance in terms of anonymization given the test sets that we are going to use, and the test set will come from the public sector data. So in a couple of months, we will be able to tell what are the performance in terms of anonymization, but also in de-anonymization. So we're working on this, and the answer will come soon.
Okay, perfect. Yeah, I was just curious if it was something like 70% or 80% or 90%, or I don't know, but yeah, let's wait and see then.
Yeah, and I think it will be more complex than just one dimension, because I think the way you anonymize different type of named entities is some are more critical than others, and we will have to give this multi-dimensional values.
Okay.
Thank you.
Perfect. No, thank you for answering. Yeah, that already brings me almost to my next presentation, because the topic is extremely sensitive. I guess when we speak about anonymization, of course, it's, sometimes more problematic, sometimes less problematic, but I'm very happy to welcome one of my colleagues, Professor Günther Neumann. He's leading the question answering and information extraction group at GfKI. And he has looked into the issue of anonymizing health records. So welcome, Günther. And yeah, we really look forward to your presentation.
Yes. Hi. So first I have troubles to open my
Okay.
So let me see. Okay. But you have my fallback.
I can also do it for you if you want.
Yeah, we can present centrally if you like.
Do you see something now, or?
We see you.
That's fine. Yeah, maybe you can do centralized. I really do not use Zoom, so I have some trouble in doing this.
Okay.
So, anyway.
You can see the presentation as well?
Yeah, I will tell you when you have to go to the next slides. Okay. Good, thank you. Yeah, so first, thank you for giving me the opportunity to present some of our works. It's actually on monolingual text anonymization in the medical domain. It's basically of anonymizing electronic health records from patients. It's done by my group members, Zadullah Amin and Noon Pokaratsiri. And I also did some work together with them. And yeah, so next slide, please. So we have heard a lot on anonymization, de-identification, and so on. And the task here is actually of more or less removing, or at least knowing which part to remove from protected health information, from patients' clinical notes. So this is usually, notes are usually those that the doctor writes about the status of a patient. It's clear that in the medical domain, it's very critical and important to do this, because on one hand side, we as researcher, we want to develop models, of course. We would like to train models to make these models available. We want to share data in that case, but of course, the patient information is very critical. And so we also have to make sure that we protect the patient's privacy. This is difficult because if we do anonymization, we also have to do it in such a way that we can actually train reliable models. So we cannot just remove the information, because that would mean we would lose a context and other sort of information. That's one thing. The other thing is that there is already kind of work in that area. For example, in the US, there's the Health Insurance Portability and Accountability Act, which defines, for example, 18 different types of these protected health information, PHI, that ranges from patient names to phone numbers. So next slide, please. So here you see to the left, the core categories: name, profession, location, age, date, contact, IDs, and to the right, you see subcategories of that. Yeah, so for example, hospital, the name of the hospital, the location of the hospital, the organization, street, city, and other kind of information. Next slide. Yeah, I think this is somehow also evident by the presentations that we had already right now, that text anonymization at least partially can be considered as a sister task to named entity recognition. We also have heard that only named entity recognition might not be enough, so we might also do what is called entity linking. In this presentation, I will concentrate and focus on the named entity recognition task. So that means we can consider each PHI category as an entity type, and then we can consider the problem of anonymization here as a problem of sequence labeling. So we have a text, and we identify spans of a text and as a named entity, and we want to add a label to it. So, okay, this is somehow not new. Now a bit more new from our point of view. We actually, I mean, it's clear that I will say a bit more next slide, but the one problem in named entity recognition, at least if we go into different domains for real tasks, it's actually we have to address data scarcity, because very often you do not have labeled data, or you only have few labeled data. So a problem or a question is, can we transfer what we learned in another domain or language to the problem domain that we have right now? And here we have just at DFKI, at our group, we have just developed a tool that we call transfer learning techniques based on transfer learning technique based for our tool, which is called T2NAIR, named entity recognition. So next slide. So this is actually a bit more on our tool. As I said, in most real world applications, we have the data scarcity problem. That is we want to mitigate this issue by transfer learning. That means we would like to apply a model, say, or transfer a model to a new domain. That is then called domain adaptation, or to a new language, to cross-lingual learning. Or we want also to support multitask learning, say, for example, merging different data from different domains. Also, I think you are at least aware of the fact that in the last few years, a major breakthrough in LLP have come from the so-called transformers or deep transformer architecture. So BERT, for example, is a prominent example of it. And we have now, that was our goal, to make this available to named entity recognition, but as a kind of a unified toolkit that would combine a lot of advances that has been achieved in that area together and provide this for named entity recognition research, especially in the context of transfer learning. So, and here our focus is on providing a research platform for researchers in this domain that can also be used in real-world use cases. Okay, next slide. Yeah, we had just the publication accepted at the European ACL as a demo paper. So our tool, which is called T2NR, you see now what it means, Transformer-Based Transfer Learning Toolkit for Named Entity Recognition. We built on top of a Hugging Face a transformer library, which is a very widely used transformer architecture library now. And we, on top of that, we have implemented and modularized a lot of existing transfer learning algorithms. The next slide. So the motivation for this is already that that a lot of advances come from deep transformers architectures, and that named entity recognition is a kind of a fundamental task in a lot of applications. For example, in anonymization, but also, for example, in relation extraction or question answering. And in real world named entity recognition, you typically have a low to zero resource scenario. That means you either have no labeled data or you only have very few labeled data. Usually, or traditionally, a sequence learning approaches based on these recurrent neural networks, LSTM, for example, have been a standard or it's a very successful approach. But in recent years, a lot of algorithms for transfer learning based on deep transformers have been developed, and that was our motivation to put these together. Next slide. So what transfer learning approaches are supported by our platform? For example, simple transfer learning. So you have a source language and you want to apply the model to a target language, so from English to German, or you have it from a specific domain, then to another domain. A sequential transfer learning that you also have sequences of different labels. We want to support supervised and unsupervised adaptation, multi and cross-task learning, semi-supervised learning, as well as few shot and zero shot learning. And we want to provide this under one umbrella, using our toolkit. So next slide. So this gives a rough idea of the architecture that we have. In the top, we have a lot of data readers to support already existing data sources that can easily be maintained. Internally, we use the CoNNL format, so it's a by IO scheme. And the architecture that we have is we begin with a kind of an encoder part from a transformer. And then we have the class to the left, then we have a classifier, which is a linear classifier or a sequential based classifier. And in between, you can add additional arbitrary neural networks. Currently, we support bi LSTMs and multi-layer transformers that you can say to plug in and to fine tune your model. We also support that the outsourcing of the model, so to speak, so that you can use them in your real world applications. And as a modular kind of way. We support a lot of, we have implemented a lot of existing algorithms, which we call trainers, and they are just available and can be parameterized and then simply used. Next slide. Okay, that's a bit background. We have, okay, if you want more, you can go to the paper and also the code you can download, this toolkit. Okay, we have now used this in an EU project called Precise4Q, which is on predictive modeling in stroke. And here we consider a lot of a number of phases in stroke. So the rehabilitation, the risk analysis that you get a stroke, the diagnosis phases and the rehabilitation phase and the reintegration phase. And in case of the rehabilitation phase, we work together with a partner hospital in Spain. That's the Goodman Institute in Barcelona, and they provide to the project a lot of patient data in that context. And in order to make this data usable in our project, we started together to use our tool and to use this for anonymizing the relevant information. So we have data, and to address this issue and to apply this to our tool, we use external open source multilingual data that is available in Spanish and English. And then we created, as part of our project, a gold standard development set. Oops. It's a gold standard development set and a small or a noisy training set for few shot training. And I will say a bit more on this small corpus. Next slide. So we, from these patient records that we have, we annotated about 4,400 sentences by 2 students that did the standard agreement checks and so on. And it turned out that of this 4,400 sentences or that belong to these patient records, only not only, but 1,500, about 1,500 contained relevant entities from this PHI data set that I consider, that I have to the right. You see, so these date, age, location, name, contact, profession. So in this, currently we only consider the course trained classes. And you see also distribution here. For example, we have about 500 text snippets, so to speak, that are belong to the label age. Yeah, next slide. So what now we did a number of experiments. So for example, we first trained with the external open source data set from Spanish, and then directly applied that trained model on our development set from Goodman. We call this the Goodman text. Then we also used this trained Spanish model and then applied our small noisy training data to do a fine tuning and then applied it on our domain. So in this sense, one could consider this as a sort of domain adaptation experiment. We also did an experiment where we mixed, or where we put together the available open source Spanish and English training set together. That's sort of a multitask learning, and applied it also to our Goodman data. And we did the same approach by using Goodman data for fine tuning. So next slide, please. Okay, here you see the experiments. So if we apply the Spanish model, which is trained on a, it's trained on different it's in the medical domain, but it's a different area usually. We and in a zero-shot experiment, we get around 73.3 F measure. If we do a fine-tuning with our small noisy data from Goodman, you see that helps really very much on 88.6 F measure. If we also put together and consider in a pre-training phase the English data, we even got to 89.5. And if we additionally use the Goodman data for fine-tuning, we obtain 91.2. So next slide, please. Here you see a distribution on the quality over across the types. Best results for age. Then and then you see further that I think date is very good processed. Not so good is the ID information, and profession is also that of course depends on, for example, the distribution on the distribution of the labels if we consider them together. Yeah. So next slide. Okay, what we also did is we randomly selected 100 patient notes in an additional experiment, just 100, another set of 100 patient notes, and we let the Goodman people annotate the data, and then we selected randomly 100 patient notes, we run our system, and we provided the output of our system to the Goodman people so that they could do an assessment of the quality. So that was, it's a kind of a blind test experiment. And here you see that we obtained actually the results that you can see here that we obtained. It's in this case 9707 F1 measure. So I think this is my last slide. Yes, okay. Yeah, that's for the moment. If you have questions, I would be happy to answer.
Yeah, first of all, thank you from me for this presentation. It's really great. I mean, what you managed. Just one quick question. I mean, how do you plan to improve the results maybe for the ID? Because 0.13, it's kind of.
I think, of course, I think we already talked about that, but I think that named entity recognition is only part of the whole problem. I think of course, we have to consider disambiguation. I mean, entity linking in that sense, but also to consider relation extraction, for example, and to compute also correlations between the named entities. So currently, somehow one could consider them as somehow context-free recognized. So we learn all dates in a patient note, but we do not consider the relationships between these. So I think this is one thing that one has to do at least.
Okay. Yeah, then we are curious to catch up. I also see that Khalid Choukri, he raised his hand. Khalid?
Thank you very much, Andrea. Thanks a lot, Gunther, for the excellent talk. You mentioned in your last slides the data that you are using for testing. And I mentioned in my previous intervention that MAPPA and very likely other projects are also conducting tests, and we will be releasing figures that will be hardly comparable because we are going to use different test sets. And my question is, how much effort is needed to ensure that we come all together with the same test set for all these anonymization toolkits that are mentioned here and there? So can we work on a common test set that will be freely available, openly available to those who want to show some tests? Thank you.
Mm-hmm. Yes, I mean, actually there exists some open source data that we also used. That's for English and for Spanish. These are usually available through these challenges, for example, that are organized by BioNLP or CLE. I don't know how much these can be considered as standard types, and then of course as a standard way to organize data. If yeah, and yeah, I think this is. I mean, it depends also. I mean, also on. I think it's also. How can I say? I mean, I'm not an expert in the medical domain actually, or in bioinformatics in that sense. But I think it might be that that for full anonymization, that might depend on the domain. No? That is, I do not know how in the medical domain. No? So I mean, it's a difference whether I annotate patient data. It could be a difference. I'm not sure whether I annotate patient data from stroke, say, or from another health area. So that is. I mean, I could imagine that one could use available ontologies, for example, ICD-10 code or maybe Snowbird CD, which are existing ontologies in that area, and to select sets of types there. But that is, of course, something that one has to investigate. I hope I answer at least partially your question.
Yeah, absolutely. Thank you very much. I just want to throw in this idea that if we develop some common test set every year, so people don't see that in advance, it would be a very nice community work, but we can discuss this offline. Thank you very much.
Yeah, perfect. Actually, that closely relates maybe to Josef's question from the chat. Did you train and evaluate your system on standard named entity recognition data sets?
Yes, but I do not have numbers right now. Yes, I mean, you can use it for full. You can. I mean, the tool that we have, we can use for to run it on the standard kernel data set. So that we can use it in a let's say in a standard supervised setting. For example, we also did some experiments to use it also for morphology, because this is also somehow a similar tagging and tagging problem. Yeah, so but I do not have numbers right now.
But I'm sure we can share that somehow later on.
I mean, the focus was more on making available a tool with existing algorithms, and yeah, but yeah, I will check for this.
Thank you. Well, any further questions from the audience? Okay, I think maybe you will still stay on for a couple of minutes just in case a question is sent in through the chat. But yeah, really, thank you for the presentation. And also a quick note, even though this only happens to come up in our last talk of today, there's the CEFAT catalog of services, where we list language tools from Europe for Europe. And well, probably it's worth listing your tool as well.
Yeah.
So I just, quickly already sent the link into the chat, but more about it later in Maria's and Pro's presentation at 2:45. But now I'm also happy to welcome our next presenter. That's Michael Rigaud from ELDA. He's the legal counsel at ELDA. And he will give you some insights into the legal aspects of anonymization, which I think is also quite relevant and sometimes also tricky, but we have to face it time after time. So welcome, Michael, and thank you for being with us today.
You're welcome. So I'll share my screen now.
Perfect.
So put in a second. Is that okay?
At the moment, we only see like the standard. Yeah, now we see the presenters mode. Perfect.
Thank you.
Thanks.
So, hello everyone. So, as Andrea kindly introduced me, I'm Michael. I'm legal expert at ELDA. So, I'm here to provide you with a legal perspective on anonymization of language resources. So, first, a bit of background regarding ERA and ELDA's mission, to give you a bit of insight of about what we do and why I'm here today to present you this presentation. So ERA's mission, ERA is a non-profit association that has been founded in 1995. Its main missions are to promote language resources within the human language technology community and provide evaluation of language technology engineering and provide services such as identification, production, and distribution of resources and evaluate systems and participate in standardization efforts. So ELDA is the ERA distribution agency. Its main expertise is in the production of language resources, especially annotation, transcription, and anonymization, as also selected in the MAPA project. So my main task in ELDA is to help in the distribution of language resources and to provide legal support mainly in the task of licensing, intellectual property issues, and also providing assistance in compliance with data protection regulation. So in summary of this presentation will be divided into 4 parts. The first is going to be a quick introduction into the principles of data protection and personal data protection with the philosophy and general principles of the Gdpr, which is the General Data Protection Regulation. The second part will be a legal definition of anonymization under the Gdpr. The third part will be a definition of the usefulness of the anonymization. Was it useful for data protection compliance? And 4, as has been requested by Andrea, a link between the proposed regulation of AI and anonymization. So first, an introduction to principles of personal data protection principles. So protection of personal data is a fundamental right that is protected by European texts, such as the Article 8 of the Charter of Fundamental Rights in the European Union. It is based on the right to privacy, which can be translated into layman's term into the right to have a private life. The main disposition in the European context is the General Data Protection Regulation that translates this right to protection of personal data into more concrete rights. So actually here today, it's the birthday of the GDPR because it's enforced since May 25, 2018. So its main objectives are to provide an harmonization of the various national laws regarding data protection. It's to create a high standard of protection for EU nationals and to balance the rights of individuals and the need for a common data market. So its scope, the scope of effectiveness of the GDPR is based on personal data only, which is defined by Article 2. It's solely focused on processing made by establishments located in the EU and to processing of data subjects located in the EU. So the GDPR provides for a legal definition of the anonymization. mainly recital 26 of the GDPR provides the following: that the principles of data protection should not apply to anonymous information, which is to include information that do not relate to identifiable data subjects or to information that has been rendered anonymous in a manner preventing identification of the data subject. So, as has been developed in the introductory talk by Marchis, these are some examples of identifying information. So there can be directly identifying information such as the name, the surname, the address, and in the case of speech data, the voice print, which is biometric data. There are also indirectly identifying information such as the IP address, profession, or any other contextual information that could help provide identification of the persons. So what is proper anonymization under legal rules? So data is considered anonymized when it can no longer be used to identify the person by all likely and reasonable means, and this process needs to be irreversible. So, as has been touched also, I wanted to provide a quick comparison between anonymization and pseudonymization, because these are two similar concepts in the light of the GDPR of data protection. So, anonymization is a de-identification of all personal information in a dataset and prevents all re-identification of the data subject, whereas pseudonymization is a replacement of identifying information with other information, and it may allow for re-identification of individuals later on. There are also more information regarding legal analysis of anonymization techniques by the former Working Party 29, which is now the European Data Board, and you can see on the link below. You will be able to see on the link below more information on how some techniques are seen from the legal perspective. So, what are the purposes of anonymization and pseudonymization? So, anonymization and pseudonymization are processes covered by the GDPR because these are because the GDPR includes all processing of personal data. Anonymization and pseudonymization are processing that are linked to personal data, and they are covered by some articles because they help perform obligations such as help the integrity and confidentiality of data under Article 5 of the GDPR. They can process from the legitimate interest of the controller. The controller may have legitimate interest to anonymize the data in order to distribute them or have them more secure. These are processes that ensure the data privacy by design and by default obligation or principle that is inserted in Article 25 of the GDPR. And also, finally, these are processes that ensure the security of datasets, especially regarding the security of the person, the names and data of the person that are included in those datasets. So these techniques of anonymization and pseudonymization, these are tools for complying with the GDPR. So as a consequence, anonymized datasets are mostly not covered by the GDPR. Sorry for the mistake. I will check. I will modify. So this facilitates the transfer of data to third parties outside the EU, but be careful because you have to differentiate between the original data set that is being made anonymous, because it's still covered by GDPR, because it still contains personal data, but the anonymized data set will be out of the remit of the GDPR. So finally, a quick insight on the proposed regulation on artificial intelligence and anonymization. So on the 21st of April 2021, the European Commission proposed a new regulation regarding artificial intelligence. So it operates a classification between various types of AI, especially as products or as security component of products, and this classification mostly depends on risk analysis. It proposes several obligations to producer or products relying on AI, such as performing security checks, having risk management, and having necessary transparency with the users. So what does it mean for the use of AI in research? The use of AI in relation to natural persons' data may be seen as high risk, independent of the intended use. So in the context of language resources, that would be for the identification purposes or for anonymization, because if you use such AI to remove the identity of person, it could be seen as high risk for them to be re-identified, or that their right to privacy would depend on an artificial intelligence. But the use of AI as such in research has not been particularly detailed in the proposed regulation. But you can be rest assured, because the process for implementing the proposed regulation should be in place in the year 2022 or 2023, depending on the speed of legislation in the European Parliament. So that's it for me. Thank you for listening, and I'll be glad to answer any question if you have any.
Yeah, thank you for this really interesting talk. First of all, are there any questions from the audience? No? At least, you know, from my side, when I was listening to your presentation, you mentioned in the beginning that that the process somehow of anonymization must be irreversible, and that well, anonymization would actually prevent all re-identification of the data subject. Is that ever possible? Can anyone ever comply with this?
In the GDPR, I think in the sense of in the spirit of the regulation, it should be in the light of current knowledge and state of the art, because in essence you're completely right, because the techniques evolve for crypting or for anonymizing, but also for de-anonymizing data. So it's always a race between the two participants. So it should be, I will check if there is any, but in my opinion, it's only seen as a state of the art. So if you study anonymization technique, you should study in the light of the state of the art, and not in the state of how in the future the technology is going to evolve. But if you perform anonymization, you also need to be aware that the state of the art evolves, and then make your anonymization technique evolve as well.
Okay. Yeah, thank you. That's great. At least we will not have to kill the people who did the anonymization if we do it manually. So, no. But just coming back also to Günther's presentation, where he had these kind of bad values for anonymizing the ID, thinking that a person is identified not just by the ID, but also by the name, surname, address, date of birth in a medical record. And given that all the other named entities apart from the ID, they are kind of anonymized properly and they were identified correctly, does it then actually matter that the ID was not maybe caught and not anonymized?
You mean the social, let's say, social security ID? It should at the social security number is a personal data, so it should be called by, I don't know if I get the named entity recognition and named entity recognition tool. So you should be, if it's not done by a machine, it should be checked by a human, because these are some of the features that are directly identifiable. A social security number, it's a key to many other personal information. So it's not highly sensitive per se, but it's really sensitive because it's a key to, it could be used to perform some many other, to have access to many other personal information.
Okay, I see. Yeah, any other questions? No. Okay, then really thank you, Michael, for all this information.
You're welcome.
We will definitely bear that in mind, when working with the data in the future. Oh, there's still one quick question from the chat. And Karina, she asks, it was, oh, sorry, now it already disappeared. It was touched in a previous talk, but I wonder if GDPR actually states whose responsibility it is to anonymize data for translation. Is it the client's responsibility, a translator's responsibility, or an agency's responsibility?
There's the only responsibility that are set in the GDPR are the responsibility for the controller, what is called a controller and the processor. So the controller is the one who has the decision to collect the personal data, but it can also be its decision to anonymize the data. So it would be in his responsibility to anonymize the data if he wants to do so, because anonymization is not mandatory. It can be used as a tool, as I mentioned, it can be used as a tool to help to be compliant with the GDPR, but it's not mandatory. It's really helpful because once you used it, you're in the clear. But and if also if the controller wants to have a third party anonymize the data so it would be then the processor, so a third party or a client of the original control would be responsible for this anonymization. But all in all, anonymization, it's useful, but it's not mandatory because there are many other ways to be compliant with the GDPR. There are so. Even though this session is mostly regarding anonymization, anonymization is just one way of being compliant with GDPR.
But what would be alternatives? Sorry for just jumping in.
Just security, information, transparency. These are all obligation. March is also explained a bit on that, to have privacy by design and by default. So to try to collect as little personal information as possible. So to be within the lines of the main principle. So have a small data preservation as possible, to have the most secure way of preserving the data, to have the person being able to exercise their rights under the GDPR. All of this allow you to be compliant.
Okay, and if the data subject consents to the use of his or her,
yeah, sure, consent.
Okay,
consent is a way to be compliant. Yeah.
Perfect. Okay. Yeah, thank you, Michael, for this presentation.
You're welcome.
And yeah, I'm sure it will be of help in all our daily lives when we have to deal with the data. Maybe just to conclude today's training, we would like to look at anonymization tools and applications, where to find them, what is out there maybe. And I'm really happy to welcome our next presenter, or well, our next team of presenters, and that's Maria Giacou and Prokopos Prokopides. They are both assistant researchers at ILSP, the Institute for Language and Speech Processing. So welcome both. And I think Maria, she will start with the presentation.
Right. Hello, everybody. Thank you, Andrea, for inviting us. Thank you also for the sneak preview into the contents of this presentation when mentioning before the catalog of tools and services. So as the title of this presentation indicates already, we're going to actually cover two main topics. The first one is to have an overview, to give you an overview of what are the currently available anonymization solutions provided by developers of language technologies in Europe. Which languages do they cover, for what type of texts they are appropriate, what text they support. And in the second part of this presentation, we will focus on a case study which regards monolingual anonymization of Greek court decisions. So for those of you who are not very familiar with the EU jargon, the acronym CEF stands for Connecting Europe Facility, and AT stands for Automated Translation. So CEF-AT is a group of services, a building block, as it is called, supported by the European Commission, which helps to crack barriers to the free flow of information within the European Union and to facilitate cross-border communication with the help of language technologies. CEF-AT provides a group of technologies, language technologies, that are developed by the European Commission or by relevant actions and initiatives and projects within the broader CEF family. And these are, you can have an overview of them in the URL that is provided on this slide. Most of you should be familiar with the well-known e-translation platform. This is the European Commission's machine translation service, which is offered for many years now, free of charge, to all European public administrations, to European universities, self-funded projects, and more recently, it has opened up access to European small and medium-sized enterprises. But apart from e-translation, this suite of tools also includes a Twitter translator, a speech-to-text engine, and automatic speech recognition engine, which is now available currently for English, German, and Spanish, but more languages are to be added. A named entity recognition tool. It also provides access to the equally well-known terminology European database, the European Language Resources Coordination Action, which we participate in as well, and to the so-called catalog of tools and services. And I will explain a bit more in detail what this is. So this catalog was developed by the ELRC sister action, the SAFE-80 Tools and Services project. It is a catalog that lists language technologies that can support all European stakeholders in their digital communication scenarios. May they be public administrations, SMEs, other system developers, or the European digital service infrastructures. It can be accessed through this URL. And what it lists and describes are services developed in Europe. So the prerequisite to be listed in this catalog is that the provider, the developer should be based in at least one European country. They can be services that are provided either by the Commission itself and the projects that it funds, or they can be third-party services, free of charge, or even commercial ones. So out of the shelf tools and services that someone can have for a fee. The tasks that are covered are not only machine translation, but also computer-aided translation tools, speech technologies like recognition and text-to-speech synthesis, conversational systems, text analytics, anonymization, which is the focus of today's meeting, and much more. If you have a look in the contents of this catalog, you can see that currently there are almost 700 tools and services listed. You can search for them by using the free text search field, or by applying some faceted filters like the ones on the left-hand side. Search for specific tools per task, per language that is supported, per country that the provider is located in, and much more. Now, in our case, I have selected for task anonymization. So 33 tools are currently listed in this catalog. Each of them has a very short description of what it is, some basic information, whether it is free of charge or proprietary, how you can access the support of the tool or service, and how you can download it if it is available as a Dockerized software, if it is available as a web service, or if the source code is available and under what license. Now, as I said, there are currently 33 anonymization services. Let me note that these may not be all. This may not be a complete list of all the European tools and catalogs, tools and services, sorry. But the catalog is in a constant development. And as you know, the LT landscape in Europe is changing every day. New services are added. Some older ones are retracted, others are rebranded. So if you are the developers or providers of any relevant language technology tool, you can of course contact us, and it will be listed and published through the catalog website. Now, what these 33 anonymization tools are about. If you do a thorough investigation of them, you will notice that less than half of them are free or open source. The rest are commercial tools and services, or consultancy kind of type of services, which means that they are developed and tailored to what the customer needs. In terms of their input type, again, almost half of them process free text. The rest are only appropriate for structured data, for instance, for database data. If my understanding is correct, most of us today in this meeting are doing research in natural language processing. So for most of our scenario use cases and applications, such anonymization tools that only work for structured data are not very helpful. We need tools and solutions for free texts. 3 of them are tailored to the medical domain. They can anonymize or attempt to anonymize clinical records. And as far as the languages are concerned, anonymization tools are always language specific. There's no language independent tool or solution. And they strongly rely on the underlying module, the NER module, the Named Entities Recognition module. So the question is, if you are looking for something to address your needs and purposes, whether these are research one or development ones, is there a fit for all solution? And the answer is most probably not. In most of the cases, you would have to tailor your solution to the specificities of the data at hand. And in this context, we're going to present to you, and I'm giving now the floor to my colleague Prokopis, how we had to handle a very specific problem for the anonymization of Greek court decisions. Prokopis?
Yes, can you hear me?
Yes.
I seem to not be able to share my screen right now.
We could do it centrally if you like.
It says that I cannot start sharing my screen while the other participant is sharing.
I think it should work now.
Yes.
Okay. Okay. Maybe. Maybe it's okay now.
Now it's perfect.
Okay, thank you, Andrea. Thank you, Maria. So, as was shown in today's presentations, anonymization is a challenging topic in many domains. And I think it becomes an even more interesting task when needs of transparency and privacy conflict, as is the case in the legal domain, where we may want to access information from, let's say, previous court decisions, but at the same time, protect the details of involved parties. So in the case presented in this part of our presentation, we focus on court decisions published in Greek, a language for which, to the best of my knowledge, there are no publicly available data sets comprising non-structured texts and their anonymized versions. On the other hand, there is a relatively large source of anonymized court decisions that can be crawled from web portals of Greece's Supreme Courts. They are 2, the Supreme Civil and Criminal Court and the Council of State. And the latter is the Supreme Administrative Court and is the highest authority on all matters of administrative law disputes, including the function of the civil service, compensation claims against the state, and challenges to the legality of administrative tasks, acts in general. So what we aimed in this preliminary work was to use NLP technologies towards, in a low resource scenario, towards developing an anonymization solution targeting Council of State court decisions. So after getting some of these court decisions in our hands, after getting them from the Council of State portal, we noticed that there were some peculiarities in these documents that made their processing very difficult. For example, the texts were word processor documents that were available as HTML pages, and they contained hard line breaks, as you can see in line 17, 18 of the screenshot on the right. They had encoding problems, probably created during conversion to HTML. Line 44 is an example of this. For specific paragraphs which were repeated across documents, there were spaces between letters and words without spaces between them, as in lines 33 and 35. These are some typography relics that still exist in these types of documents. And most crucially, entities like persons, addresses, their addresses, acts and previous decisions were replaced by ellipses. And there was no access to, of course, for obvious reasons, to non-anonymized versions. So to overcome all these issues, we have tried to compile a development dataset, a small development dataset, in order to start handling documents of this type. We corrected some of the errors using custom normalization scripts for dealing with paragraph, word, and character segmentation issues and encoding problems. And again, the most important transformation at this stage was the manual replacement of anonymization with artificial but plausible, both semantically and morphosyntactically, entities. These entities included person names, street addresses, numbers of previous court decisions, etc. And so we created a small development dataset with 7 pairs of non-anonymized, in quotation marks, and anonymized documents. Then we pre-processed this small dataset with a neural NLP toolkit for Greek, a language with complex morphology, and the output of the toolkit includes highly accurate annotations, automatic annotations for part-of-speech tags and lemmas, annotations which were used in later modules in the anonymization process. Our toolkit also includes a relatively accurate neural named entity recognizer, which has an overall relatively good accuracy, but is more robust in the detection of person named entities. The named entity recognizer module also uses patterns. It's a hybrid tool. Also uses patterns to recognize specific entity types. So the label set of the named entity recognizer includes the classic person, geopolitical entities, location, organization, named entities, but also phones, emails, and URLs, and some very specific named entities like IBAN bank accounts, and also national security numbers and tax office numbers of the Greek state. Moreover, the NEs recognized include court decisions and other legal documents like laws. So following this pre-processing stage, the core of the anonymization solution involves 2 stages. For the first, we developed pattern-based rules using the J pattern matching language to detect zones in these documents where phrases to be anonymized typically occur. These zones include paragraphs where the names of involved parties and their addresses are listed, as is the case of the 4 first highlighted paragraphs in the example on the right of this slide. The rules also aim to detect paragraphs where the court decision is presented and explained, as is the case of the other sequence of highlighted paragraphs in the example screenshot. All the other paragraphs which are not highlighted in this example typically contain names of judges and other members of the judicial procedure, which we do not want to anonymize. Following, of course, the example of the crawled anonymized versions where these names were not masked. So if we move on to the next stage, we have another set of pattern-based rules targeting phrases that are typically named entities or named entity combinations and occur inside the zones detected by the previous set of rules. These phrases are highlighted in the example on the right, and a label mask is generated for each one of them. Of course, instead of the mask label, we could have replaced the phrases with ellipses, or we could have replaced them with initials corresponding to the phrases. Apart from the rules that mask these entities, there are also rules that may undo masking in specific contexts. For example, and I invite you everyone to try to read some Greek here. For example, in the third paragraph after the headers of the document, we have a person named entity followed by an ID number in parentheses. However, this number is the person's ID in his professional association. However, this NE is not masked for anonymization, since the this named entity follows a word lemmatized as dikigoros, attorney, which is the Greek word for lawyer or attorney. And the same pattern occurs also on the next paragraph, and the named entity there corresponds to the legal representative of the other involved party. Regarding evaluation of the anonymization rules, although we do not have a large evaluation set available, and so we do not have hard figures here, first results on this small development set indicate good performance for persons, addresses, and previous court decisions. On the same development set, the detection of the anonymization zones by the set of rules presented on the previous slide seems highly accurate. To summarize, Maria presented a wealth of interesting resources available at the CEFAT catalog of tools and services, and these resources are related to, among others, anonymization. And we presented also a rule-based anonymization solution for court decisions by the Greek Council of State. We have observed promising first results on a small development dataset built from these documents. And this solution may be useful for, may be potentially useful for learning a neural text segmentation and anonymization module, for helping in actual anonymization in courts, and for the development of an anonymization training evaluation dataset where this work and others could be more formally assessed. Thank you very much. Thank you for your attention, and we will be happy to answer any questions.
Yeah, it is also neat to thank you and Maria for being here today. Just maybe a quick question. When you mentioned that there has been some good performance on the small development data set, what does it mean actually?
It means that it is around something like 90% accuracy, but I would not want to include these figures in these slides because this is very preliminary work, and we are working still on fixing the evaluation data set and performing a more concrete evaluation.
Okay, but I see, I mean, it's definitely promising, so.
Yes.
Perfect. Are there any questions maybe from the audience today? No? Okay. Yeah, then thank you both again for being here today. I think it's a good outlook, and it's definitely promising work to go ahead with, and we also keep an eye on it because after all, I mean, this is something which happens every day. Court decisions must be published, and this should be done in a well, hopefully automized way, and also in a safe way for the data subjects. So really, just looking back at today, I can only say that really it was packed full, you know, with interesting presentations and insights. We looked at the anonymization in really different contexts and areas. Anonymization of the medical records, of court decisions, anonymization of parallel data, anonymization of speech data, tools and services that are available in Europe, and last but not least, also the legal frame for sharing language data and for anonymizing language data. So it's quite a bit, which means that we can really look back at today in a very positive light, because there were quite a few lessons learned, I think, for all of us that we can then take home with us for our future work and activities. And yeah, that's why I would like to thank you, well, first of all, to all the presenters who were here today. Thank you for your availability in the first place. And thank you for sharing your knowledge and expertise with us today. And also thank you for answering all our questions. At the same time, I would also like to thank all the participants today. Thank you for your interest. Thank you for your comments, for your questions, for being here with us today. Because without this, we would not have learned as much as we did. And also, I would like to thank some people who you may have gotten a glimpse at, but who unfortunately were largely invisible today, but who brought this event alive and who really provided all the necessary technical and organizational support that it takes to make this event happen. So thank you to my colleagues, Aline and Stefania. Really thanks for all your support today. So I think when closing this training session today, I also hope I will not have to say really goodbye to you. And instead, I would really like to wish you a wonderful afternoon and evening only, and say, let's stay in touch. I promise that we will send to you all the information around today's event, so that you can also find the presentations that were given today. And at the same time, you are invited to join our future events, like, for instance, our scientific webinar series on neuro-machine translation for low-resource languages, which I mentioned in the beginning, and which starts on Tuesday, the 8th of June. So that's pretty soon already. Or maybe you would still participate in our shared task at the WMT 2021. We are really, really looking forward to seeing you there or in all events. There's a lot coming up. So just stay tuned and we will keep you updated as promised. And yeah, I really look forward to seeing you soon again. Thank you and bye-bye.
Thank you. Bye.
Thanks.
Thank you.
Thank you. Bye-bye.
Thank you very much. Thank you.
Thank you all. Bye.
Thank you all.
Thank you very much, Andrea. That was very informative.
Bye.
Bye-bye.
Bye.